Correct? Same is the case with demux also. Let us say, for example, I need to write a demultiplexer. Now let's say I have to write a 1 cross 8 demultiplexer. Very simple. Always at star. Okay. Now my assumption is I have a output bus which is 7:0. Okay. Now in the beginning of always I will assign output underscore bus of 7:0 to 8 tick B0. Then I have a integer I. For I is equal to 0, I less than 8, I equal to I plus 1. Begin. If I is equal to select, then what I should do? OP underscore bus of I gets input. This input is a 1-bit signal which needs to be sent to any one of these 8 lines depending upon the select. That's what is a demux, correct? Yes or no? Correct? I have, this is my output and my input is, there's a 1-bit signal called input. This is my input which is 1 bit. Correct? And I have a select line which is 2:0. So if my I matches select, that bit of my output is assigned to my input. Remaining all the bits are no problem because I am assigning it to 0 initially. This is like initializing the output bus. So output bus is initialized to all zeros. Now if this condition is met, always I am exploiting the see, this is the beauty of blocking statement. I am exploiting the functionality of blocking statement. Now see, here what is going to happen if I write it down? Output bus of 7, 6, 5, like this till everything is becoming 0. Correct? Now we clearly know in blocking statement that it's going to get executed line by line. Correct? So first this assignment is happening. So all of them are initialized to 0. Now then the for loop runs. This for loop is evaluating the expression. Correct? This is evaluation. This is not instantiating any hardware multiple times. It's not replicating any hardware. It is just checking for this condition. It is evaluating this condition this many times. At one place, this condition will be matching. Because cell is taking only one value, at one place this condition will be matching. At that time, output bus of I. So say one of this bit is matching. Only for that bit, the value will be replaced with input. So remaining all of these fellows will remain at 0. So this is exactly is the demux. So whenever I need to write a very wide mux or a demux, the for statement is very handy because I need to make multiple evaluation here. Correct? In case of this mux or demux, I need to make repeatedly multiple evaluation. Correct? I need to check for every input whether where the select line, according to the select line, I need to wire the input to the output or output to the, means any one of the inputs to the output, single output, or one input to any one of the output lines. See, the previous one is a mux. Now the what I said later is a demux. Correct? So this is a very interesting example for the for loop. Okay, this is the for loop or the for statement. Kindly note, I am using this for inside the always. Please note, in the previous example also I am using this for inside the always. Okay. Okay, but that's not going to be the case always. Now let's look at the other that is me for generate. Now I want to generate multiple hardware. Now what is the reason? Whatever may be the reason, we will look into the reason later. For some reason, I want to instantiate a hardware multiple times. So at that time, let's say for example, I want to make 500 instances of a AND gate. Now I don't want to write this 500 instances of AND gate manually. Say for example, if I want to instantiate the AND gate 2 times, I can do that, right? Say for example, I will say AND U underscore AND 1 dot A dot B dot Y, correct? And similarly AND U underscore AND 2 dot A dot B dot Y, correct? I can do this. But if I have to instantiate a AND gate 500 times, I have to write this line these 500 times. This is clearly a bad way of coding, right? It's a very bad way of coding. So I can use for generate here. See, clearly for generate is for replicating the hardware. For generate is for replicating the hardware. Now how can I use this? It's going to be, I'm going to say genvar I. That means I'm going to use this I as a generate variable. Then there will be a keyword called generate. So first of all, this is used outside always block. This is not for evaluation. Okay, generate. Now we are going to say for I equal to 0, I less than say 8, I equal to I plus 1. Begin. Now here I will say and U underscore and dot A of I, whatever is the signal. Okay, or I will say input of I dot B input 2 of I dot Y, say Y of I, end. And for this generate also I should say end generate. What this is going to do, let us assume. So what this is going to do is, it is going to instantiate AND gate this many times. How many times the loop is going to repeat, that many AND gates will be created. So in this case there are going to be 8 instances of AND gates. Like this, there are going to be 8 instances of AND gates. Each AND gate by itself has a B and Y pin. Okay, now this is the 0th AND gate, this is the first one, this is the 7th one. So how you are making the connections? The first AND gate A input is connected to in of I. That means this is connected to in of 0. B input is connected to in 2 of I. That means this is connected to in 2 of 0. And the output Y is connected to Y of 0. Again the loop repeats. I is now 1. So this will be connected to in of 1, in 2 of 1. This will be connected to Y of 1. The loop repeats again. Like this, the loop repeats overall 8 times. So I will be 7. So this will be connected to in of 7. This will be connected to in 2 of 7. This will be connected to Y of 7. And then the value of I will become 8. This condition will fail when I becomes 8. So It will come out of the for loop and it will come out. That means this is replication of hardware, correct? Now why we need to replicate hardware? There is a need to replicate hardware, whatever may be the reason. In my case, there is a need to replicate hardware. One simple example I can think of is